Welcome back, everyone. This is part 2 of tutorial number 6 covering analysis of variance in SPSS. I'm going to pick up right where we left off last time, which was looking at the output from comparing the means for the file data_7_1. So please get your output file out and let's continue having a look at it. When we finished with video number 1, we had just discovered that the Levine's test indicated no violation of the assumption of homogeneity of variance, and the ANOVA table gave us an F ratio greater than 4, which was statistically significant, which leads us to reject the null hypothesis and conclude that all means are not equal, but we haven't done any subsequent follow-up tests to assess, what we haven't done is looked at the planned contrasts or post hoc tests yet, which will give us some idea of what those significant differences are. So that's what we're going to do right now. Just as a reminder, we explored our data, so we have the descriptive statistics from exploring, tests of normality, some QQ plots, and then the output from SPSS involved another table of descriptive statistics that's a little bit more compact. The Levine's test gets its own table. Because the Levine's test indicated no violation of homogeneity of variance, it wasn't statistically significant. We report the F ratio from the main ANOVA table. If it had been statistically significant, if that Levine's test had been statistically significant, indicating a violation of homogeneity of variance, we would have reported either Welch's F or Brown-Forsyth's F. They both of those tests produce the same result as the regular parametric, all assumptions valid F ratio, which is that there is a statistically significant effect that not all means are equal. Right? Which means we can move on to the contrast coefficients and the contrast tests for the planned contrast. So here's those two tables. The contrast coefficients table is really just a reminder of the contrast that you specified. And the way to read our -2, 1, 1 is that we are testing the hypothesis that attitudes in the no support group are different from attitudes in those other two groups where the teachers did receive some support. So the hypothesis that we're specifically interested in is the alternative hypothesis. No support is different from some support. So these are the contrasts we use, -2, 1, 1 for that. We could just as easily have used +2, -1, and -1. We would get the same result because the contrast coefficients don't actually specify a direction. Now, for Psych 202, we're not really going to go into the math behind the contrast coefficients, so don't worry about that. What's important for you to know right now is that this is a specific test of a specific alternative hypothesis. But let me know in the questions for the unit coordinator forum if you are interested in the math, and I can recommend some additional reading for you. So what we're really interested in is this contrast tests, this second table, which has the results of the planned contrast. Now, what we've effectively done is divided our 3 groups into 2 groups, so we're kind of combining the teacher aid group and the peer support group. So one way to think about that is if we had no support and some support, we could do an independent samples t-test, and you can see that that's exactly the output that we get when we do a planned contrast. Just like with the independent samples t-test, our contrast test table has 2 rows, one for the test that assumes equal variances, that's the student's t-test, and one that does not assume equal variances, which is the Welch's t-test. You can see they've got different t-scores, different degrees of freedom, and different p-values, but the same contrast value and standard error. Recall from video 1 that our Levine's test was not statistically significant, which means that we are okay to assume equal variances, which means that we are going to report the result shown in the first row of the contrast tests table. And what that result indicates is that the contrast that we tested is statistically significant. So that's an indication that our specific alternative hypothesis that no support produces different attitudes than some support is a better model, better description of these data than the null hypothesis that all groups are equal. By combining the result of the contrast test table, which says that the planned contrast that we did is statistically significant, and the descriptives table that tells us that the no support mean is lower than the other two means, we can conclude that attitudes of teachers without support were significantly less positive than attitudes of teachers who did receive support. Again, what that means is that this planned contrast supports the hypothesis that attitudes of teachers who did not receive support were significantly different, specifically significantly less positive than attitudes of teachers who did receive support. And if we want to, we can report that with a t-score and the degrees of freedom and the t-value and the p-value. When you want to know which groups are statistically significantly different from each other, and you want to look at all possible pairwise comparisons, the way to do that is post hoc tests. So we can look at the first table in post hoc tests, the multiple comparisons table, and we're in the same situation, right? We selected two different types of tests, one that we would use if homogeneity of variance was valid. We had equal variances, which is the case, and another that we would look at if homogeneity of variance had been violated, which was not the case. Right? The Levine's test indicated that our variances are homogeneous, so we're going to examine Tukey's honestly significant difference, and if the Levine's test had indicated a violation of the assumption of homogeneity of variance, we would have looked at the Games-Howell instead. We didn't know before we ran the test whether we would want to look at Tukey or at Games-Howell, so we selected both of them. All right, so looking at these Tukey honestly significant differences, what we get is a mean difference. This is the mean difference. This is just the difference between the mean for group I, which is the first column, and the mean for group J, which is the second column. The standard error, the p-value associated with this, so is this difference a statistically significant difference? And then a 95% confidence interval on that mean difference, just like we've seen in t-test tables before. So let's look at the first comparison. We've got the no support group versus the teacher aid group. This mean difference of negative 3.6 means that the teacher aid mean was 3.6 higher than the no support group mean. So we've got a standard error of 1.229, a p-value of 0.018, which means that this is statistically significant at the 0.05 level. That asterisk by the negative 3.6 means the same thing. So it tells us the same thing, that the mean difference is statistically significant at the 0.05 level. Another way we can tell is that the 95% confidence interval, this is using the t-distribution instead of a normal distribution. All of those numbers are negative, so they don't include 0, which tells us that the scores, the attitudes for the no support group were significantly less positive than the attitudes of the teacher aid group. Attitudes of teachers in the no support group were significantly less positive than attitudes of teachers in the teacher aid group. Now we can look at the next comparison. So we're still looking at no support group as group I, and then group J is the peer support group. So here, the mean difference of negative 1.4 means that the mean for the no support group was 1.4 lower than the mean for the peer support group. We've got the same standard error, but this time we've got a p-value of 0.499, which is greater than 0.05. So that suggests that this is not a statistically significant difference. And that's confirmed by the 95% confidence interval, which ranges from negative 4.45 to 1.65. So the way to interpret that is that plausible values for the true difference between receiving attitudes when you receive no support versus attitudes when you do receive peer support is it could be that no support produces scores as low as 4.45 lower than the peer support, or they could be as much, plausibly, as much as 1.65 higher. So that 95% confidence interval includes 0, which is another way of saying that this difference is not statistically significant. All right, we could go down to the next row where we've got teacher aid versus no support, and you'll notice that's a mean difference of 3.6. That's because looking at teacher aid versus no support is the same, just in the opposite direction as looking at no support versus teacher aid. So we don't need to look at that one. So the next comparison we can look at is teacher aid versus peer support. The mean difference there is a little bit bigger than no support versus peer support. So the teacher aid mean was 2.2 higher than the peer support mean. But again, not statistically significant. So that p-value is greater than 0.05. And the 95% confidence interval includes 0. So the teacher aid score could be as much as 0.85 lower than the peer support score, or as much as 5 points higher than the peer support score, based on the evidence that we have collected. So that tells us that that's also not statistically significantly different. And then the rest of the Tukey HSD table, again, is just comparisons we've already looked at, but in the opposite direction. So we've already looked at all 3 possible comparisons. The no support group was significantly less positive in their attitudes than the teacher aid group, but there are no other statistically significant pairwise comparisons. The homogeneous subset table looks at groups that are not statistically significantly different from each other. So if 2 groups are not statistically significantly different from each other, they form 2 or more groups. Any groups that are not statistically significantly different from each other form a homogeneous subset. So this table tells us that there are 2 homogeneous subsets in this data. The first one consists of the no support group and the peer support group. And you can see that's that 0.499 that we've seen in the pairwise comparisons table above. So no support and peer support are not statistically significantly different. They form a homogeneous subset. And then also peer support and teacher aid were not statistically significantly different from each other. They form a second homogeneous subset. So this is sort of a second way of saying the same thing. And whether talking about or interpreting the pairwise comparisons table or the homogeneous subset table makes the most sense can depend on what comparisons you're looking at and how the results turn out. So it's good that they automatically give us both. And I would recommend looking at both, but in terms of interpreting them, they provide the same information. So you can use whichever one makes more sense to you in terms of reporting those results. Now I'm going to show you the mean graphs. What I want to point out is that this is just the group means. They're not showing us anything. This SPSS output doesn't show us anything about how much variability there is within each sample, so it's just a graph of group means. And the y-axis scale does what SPSS always does, where the minima for the y-axis scale is not a theoretically important variable. It's just sort of the closest whole number to the minimum actually obtained value that we're graphing. And similar for the maximum. So we're using the space as best we can. So that's always going to make it look like there's a big difference between groups. So that's important to bear in mind. But particularly when you have multiple groups, and when we get to topic 8, we're talking about more than one factor, looking at graphs of means, even without the error bars, doesn't tell us anything about whether groups are statistically significant, but it can be really helpful in terms of visualizing what the differences are. Remember that F ratio just tells us that all groups are not equal, but you might look at this mean plot and then say, okay, well, I know that there's a difference somewhere. If any groups are going to be different, it would be teacher aid versus no support. Okay, so that's the SPSS output, but we're not done yet. We've got what the Pink Book calls on page 84 follow-up analyses. The Pink Book reports a couple different methods of examining follow-up analyses. I'm just going to report eta squared. So eta squared is an R family measure effect size. It reports the proportion of variance accounted for by the factor variable, in this case the independent variable. It's an R family measure in the sense that 0 means none of the variance in the 30 different observations is explained by group differences. It's all random. And an eta squared of 1 would mean that all of the variance in attitude scores is explained by the group differences. The only way you would get that would be if all of the teachers in the no support group had the exact same attitude score to each other, which was a different score from all of the teachers in the teacher aid support group, but those were all the same as each other. And then the ditto the peer support group. All of the scores for the peer support group would be the same as each other. So the fact that an eta squared is closer to 0 than it is to 1 doesn't necessarily mean that there's not a large effect or a clinically important effect or an interesting effect, because it would be you wouldn't expect under normal circumstances. You can have effect sizes that are in the 0.1, 0.15 range that would be considered important effects. And for something like this, where you've got lots of different teachers who presumably have different levels of experience and different types of classrooms and had different experiences with the support that they did or did not receive. So you would expect some variability that had nothing to do with the independent variable and some variability related to limitations on the experimental control that you have even within your independent variable. So you wouldn't expect an eta squared of anywhere near 1, but I'm showing that to you to remind you that the possible range of values for eta squared is the same as the possible range of values for r squared, which is between 0 and 1. Now, the way we calculate eta squared with a one-way between groups analysis of variance is super easy. It's just the sum of squares between divided by the sum of squares total. If you think about it, the total sum of squares is sort of one way of capturing all of the variance, all of the variability that exists in your sample. So all of the variance between different observations. Sum of squares between is an estimate of the difference between groups. Right? So the differences between group means. And because we've only got one independent variable, this is a one-way analysis of variance, the only possible sources of variance are the variance between groups and the error variance. So all of that within variance must be error variance, and there's nowhere else that variance can exist. So we can just divide SS between by SS total, and we can get those values from the ANOVA table. And note that even if we'd had a violation of homogeneity of variance, we could still use this table to get the sum of squares. The sum of squares doesn't change, even though the F ratio and the degrees of freedom do. So here's our ANOVA source table. Here's our between groups sum of squares and our total sum of squares. We just plug those numbers in to our fraction, divide 65.867 by 269 by 0.867, and what we end up with is 0.244. So like I said, that's closer to 0 than it is to 1. But what that means is that 24.4% of the variance in this data set, almost a quarter of the variance in teacher attitude scores, can be explained by the group differences, the groups that the teachers were assigned to. So a quarter of the variance, that's enough that if it were my objective as a researcher or as a policymaker or as an educator or something like that to improve teachers' attitudes about mainstreaming students with disabilities, that would suggest that what I really need to do is put teachers' aides into every classroom, and I can significantly, substantially improve teachers' attitudes towards mainstreaming. Right, we probably also want to report effect sizes on the planned contrast because we had a statistically significant result. Remember, with the planned contrast, we've effectively divided our 3 groups into 2 groups by combining group 2 and group 3, the teacher aid and the peer support groups. And we can report the same type of effect size that we have before, right? Cohen's d is the difference in standard deviations between 2 means. And in this case, because the hypothesis, the specific alternative hypothesis that we were testing for our planned contrast was that the attitudes for no support would be different than the attitudes for teachers receiving some support, that's the comparison that we're making. So we're basically combining the teacher aid and peer support groups. Now, we could calculate combined means and standard deviations and calculate the Cohen's d the way that we would just as if we'd done that independent samples t-test from the very beginning. However, we don't actually need to do that because another way of expressing Cohen's d is this 2 times the t-score divided by the square root of the within subjects or the error degrees of freedom, within degrees of freedom. And we can get that information from the contrast table. Right? So the planned contrast table reported a t-score and a degrees of freedom. So we can just take those numbers and plug them into this equation up here. By the way, I did some testing on this because I hadn't seen this specific way of expressing Cohen's d before, but I checked it out and it does check out. If you combine the aid and peer groups and treat them as you recompute teacher aid scores, treating those 2 groups as one group, and then do some descriptive statistics, you get a mean for the sum support group of 12.9 with a standard deviation of 2.845. And you can recall from our descriptive statistics table that the no support mean was 10.4 with a standard deviation of 2.875. If you input those means and standard deviations into an online statistics calculator, like the Daniel Soper statistics calculator, what you get is an effect size, a Cohen's d effect size of 0.874. Now, when we take this formula here, 2t divided by the square root of the within degrees of freedom, what we get is 2 times 2.348 divided by the square root of 27, which is these numerator and denominator, which gives us a Cohen's d of 0.903, which is close enough to what I get just from approximately combining the aid and peer groups into one sum support group, that I'm satisfied that I'm doing the same thing. But if you want to check that for yourself, one of the things you could do is recode your independent variable so that groups 2 and 3 are one group, and then do an independent samples t-test, and then calculate an effect size for that independent samples t-test. That's effectively what we've done when we use this formula to get our effect size. And we get something that is within rounding error the same effect size. All right, so that's the planned contrast. We also did some post hoc tests, and in those post hoc tests what we found was that the only two groups that were statistically significantly different were the teacher aid group from the no support group. Now I'm not going to go through calculating effect sizes for pairwise comparisons that we found were not statistically significant. If you're being a completist, that's not a wrong thing to do. Certainly APA would suggest that that's good information for someone to have, but I'm pretty sure that if we go through this one example, given the information that you've got in the pink book on how to do this, you could calculate the effect sizes, the Cohen's d effect sizes for your other two pairwise comparisons in this case. So again, instead of comparing no support versus some support, we want to compare no support versus teacher aid. Now those mean comparisons, the pairwise comparisons table, don't give us a t-score, but fortunately, you may or may not remember from topic 6, the formula for the t-score is just the mean difference divided by the standard error. So we can input those two numbers into our equation and we get the same result. So we can get that t-score from the mean difference and the standard error reported in the Tukey HSD table. So 2 times the mean difference, which is negative 3.6, divided by the standard error of 1.229, all divided by df within, which again is the same degrees of freedom as we've been using all the time, 27, even though we're not including all 27 of those observations in this analysis. So 2 times negative 3.6 divided by 1.229 divided by the square root of 27 gives us this number, which ultimately gets us to negative 1.13. And again, I did the same thing. I input the means and standard deviations for the no support group versus the teacher aid into the Daniel Soper statistics calculator. And what I got was an effect size of negative 1.25, which is pretty close to negative 1.13. I'm satisfied that that's within rounding error. And in any case, that's a pretty big effect. They're more than one standard deviation apart. Okay, so between video 1 and video 2, we checked assumptions. We looked at what the F ratio was, we determined that there was a difference, and then we looked at planned contrast and also post hoc tests, although really if you were doing this in an honors project or something like that, you'd probably only look at one or the other. The last thing I'd like you to do is try writing up these results, right? But what I'd like you to do is have a go at writing them up yourself, and then we'll come back and go over my example in excruciating detail. All right, I'll see you soon. Okay, welcome back. We're almost to the end of video 2. Now, because my results are, I know it's 2 paragraphs, but they might be a little bit hard to see in your computer screen, so I'm going to look at them a sentence at a time, divided up into the two paragraphs. So this slide is just to give you a sense of what the whole picture looks like. So starting with the first sentence, to test whether receiving support affects teachers' attitudes towards mainstreaming of students with disabilities. I pulled that more or less directly from my research question. 30 teachers were randomly assigned to receive no additional classroom support, support from a teacher's aide for 3 hours a day, or support from a weekly peer support group. This is maybe a little bit more detail than you need to provide in results section if you've written a whole report, because you've probably just gone over in a lot of detail those groups in your method section. So if someone has just read the method section, they might not need that detail, but because we're just making up a results section separate from the rest of what this paper would be, I've included those details. All right, table 1 shows descriptive statistics for each group. Now, I haven't actually included a table 1, and I'm not going to, but this is a circumstance where you might report the descriptive statistics, that is the sample size, means, and standard deviations, in the text. And if you want an example of how that might look, I think the Pink Book has done a very nice job of that. So you could absolutely do that, particularly as there are only 3 groups here. Imagine instead of 3 groups, we'd had 4 or 5 or 6, then incorporating all of those means and standard deviations and sample sizes would get a bit repetitive and a bit boring. So one way to address that is to include a table of descriptive statistics. So I haven't actually included the table, but I wanted to let you know that that's one way to get your descriptive statistics into your results section. You have to include for each group a measure of central tendency and a measure of dispersion. It's good practice to be specific about sample sizes for each group, in particular if sample sizes were not equal, which was not the case here. But it can be more efficient, more compact, and less awkward to do that in a table rather than in text, particularly if you have a lot more than 3 groups. So I'm pretending that I've done that. I've included a table of descriptive statistics, and specifically in this case, because all of my samples were normally distributed, the descriptive statistics that I would include would be sample size, mean, and standard deviation. So those 9 numbers would appear in a separate table, which means that I don't need to repeat them again in the text. Okay. As we've said before, you probably wouldn't necessarily see a sentence like this: visual inspection of quantile plots of attitude towards mainstreaming, and I'm abbreviating that ATM scores, indicated scores for all groups were approximately normally distributed. I'm using the acronym ATM there so that I can use it later on in my results section. If I had written a complete report, I probably would have already used whatever acronym I was going to use for that attitudes towards mainstreaming score, in which case I could just say ATM scores even though I hadn't used the acronym already in the results section. And similarly, you might or might not see a sentence like this in publications, but for you while you're learning, it's good that you let your markers, your instructors know that you did check assumptions, that you knew to look at the assumptions. So here I said a Levine's test on sample variances was not statistically significant. I reported the F ratio with 2 and 27 degrees of freedom. Remember, we've got 2 numerator degrees of freedom because we've got 3 different groups. And then 27 denominator or within or error degrees of freedom because we had 30 observations total. So 27 is 30 minus 1. We've got 29 total degrees of freedom. 2 of those are the between groups degrees of freedom in the numerator, and the other 27 go in the denominator. So that F ratio equals 0.19, and I've included the leading 0 there because it is possible for an F ratio to have a value greater than 1. So I've included the 0 just to let copy editors know that that's not an error, I haven't mistyped anything. And then when I report the p-value, it's not possible to have a p-value of 1.83 or anything like that. So the 0 is implied, so adding the 0 doesn't tell the reader anything. There's no chance if I just write 0.83 that I've mistyped or that I've forgotten to add the 2 or something like that. So I can just type 0.83, I don't need the 0. Anyway. Levine's test on sample variances was not statistically significant, indicating that the assumption of homogeneity of variance was not violated. So we've got no violations of assumptions. So we can move on to the second paragraph. A one-way between groups analysis of variance. So I've been very specific about what type of analysis of variance. It's one way. I only had one independent variable. Between groups, I was looking at independent samples. Analysis of variance. Because there is no point in the rest of this paragraph where I say analysis of variance again, and there is no rest of the document because we're only writing up these results sections, I don't need to include ANOVA as an acronym, so I haven't. One way between groups analysis of variance on ATM scores and revealed a significant effect. And that's a pretty generic term. Significant effective type of support. Again, I've got an F ratio with 2 between groups degrees of freedom because there's 3 groups, 27 within or error degrees of freedom. Then I've reported the F ratio of 4.36, P equal to 0.02, and then here I'm reporting my partial eta squared of 0.24. Remember, just like p-values, partial eta, my eta squared of 0.24. Just like p-values, eta squareds take on scores between 0 and 1. So it's impossible that I've forgotten a number here, so I don't need to include the 0 for the eta squared score. So that's my main result. Couched that in words, a one-way between groups analysis of variance on ATM scores revealed a significant effect of type of support. So I've said in words what type of test I've used, what was my dependent variable, that the result was statistically significant, and what my independent variable was, all in words. Next sentence, post hoc analyses, Tukey's honestly significant difference using an alpha of 0.05. So post hoc analyses indicated that teachers with no additional support had significantly lower ATM scores than teachers receiving daily teacher aid time. Here I've reported the effect size. I don't, strictly speaking, need to report the sign of the effect size. I could just say D equal to 1.13. And here, what I should have done is also reported a mean difference of negative 3.6, which was our mean, so that it doesn't look like the 95% confidence interval on the difference is on the Cohen's d, because I've said that it's for the mean difference, but if I said for the mean difference of negative 3.6, that would make it a little bit clearer. And then the last sentence, there was no significant difference between ATM scores for teachers with no additional support and teachers in the peer support group, or between ATM scores of teachers in the peer support group and teachers receiving teacher aid time. So you'll notice in both post hoc analysis sentences, I've been sort of vague about the test statistic. I haven't reported a test statistic to report the post hoc analyses. I've just said whether they were statistically significant or not. Now that's convention. That's not unusual. With these last two comparisons, I could either have gone into much more detail for each of these two comparisons and written a sentence that's more similar to the previous sentence where I report Cohen's d, or I could have gone into much less detail and just with this sentence said there were no other statistically significant differences between groups. The end. All right, that's all I have to say about this particular example. So because I like to end most videos with a reminder to save, if you haven't saved your output file, please do. In the third video, we are going to start with a second example, and we're going to go over it in much less detail. We're not going to write it up in SPSS, so hopefully it will take less time. All right, thanks so much, everyone. I'll see you in video 3.